The pre-dawn darkness of June 4th, 1942 hung over the Pacific like a burial shroud. Aboard the aircraft carrier USS Enterprise, Lieutenant Commander Wade McClusky stood on the flight deck, watching his dive bomber crews perform final checks on their Douglas SBD Dauntless aircraft. The carrier's wooden deck vibrated beneath his boots as the ship's engines drove her through calm seas at 32 knots, a speed that would have seemed impossible for a vessel displacing nearly 20,000 tons. In 90 seconds, Enterprise would begin launching 36 aircraft into the uncertain sky above the Central Pacific. The Japanese carrier force somewhere over the horizon had no conception of what was coming, no understanding that American carrier operations had evolved into a choreographed symphony of mechanical precision that could put strike packages airborne faster than any navy in the world. The capability McClusky was about to witness represented 3 years of intensive training, doctrinal evolution, and engineering refinement that transformed American carrier aviation from a promising concept into the deadliest weapon system yet devised for naval warfare. Japanese naval aviators, products of the world's most experienced carrier force, operated under assumptions about launch cycle times that American carriers had already rendered obsolete. Those assumptions would cost them 4 fleet carriers in the next 6 hours. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Enterprise had been commissioned in May 1938, the 7th ship to bear that name in United States Navy history. Her designers at Newport News Shipbuilding had incorporated lessons from earlier carrier construction, creating a vessel that balanced aircraft capacity, speed, defensive armament, and damage resilience. At 809 feet long with a flight deck width of 114 feet, she represented the culmination of American carrier development between the world wars. But her physical dimensions told only part of the story. The real revolution lay in the operational procedures her crew had perfected through endless drills and exercises. American carrier doctrine emphasized rapid launch and recovery cycles, recognizing that the side which could get aircraft airborne fastest would likely strike first in any engagement. This seemingly obvious principle required solving complex logistical and mechanical challenges. Aircraft had to be spotted on deck in precise sequence. Engines started simultaneously, catapults prepared, and launch intervals coordinated so that planes departed in steady succession without creating dangerous gaps or collisions. The Japanese Navy had pioneered carrier aviation and possessed tremendous experience, but their launch procedures remained more conservative, prioritizing careful preparation over raw speed. The tactical implications of this difference would prove decisive at the Battle of Midway, but the gap had been widening for months as Enterprise and her sister ships refined their techniques through combat operations in the Marshalls, at Wake Island, and during the Doolittle raid on Tokyo. Each operation provided data that flight deck officers analyzed obsessively, shaving seconds off launch times, improving aircraft spotting patterns, and training deck crews to operate with assembly line efficiency. Commander John Crommelin, serving as Enterprise's air officer, had supervised the development of procedures that treated the flight deck as a precisely timed production line. Aircraft were positioned in launch order with their engines already warmed and pre-flight checks completed before the signal to launch. Deck crews moved with choreographed precision, each man knowing exactly where to position himself and what task to perform. The ship's 2 hydraulic catapults could accelerate a loaded dive bomber from 0 to 70 miles per hour in less than 3 seconds, providing the velocity needed for safe flight when natural wind over the deck proved insufficient. On the morning of June 4th, Enterprise prepared to launch the largest strike she had yet assembled. Intelligence indicated Japanese carriers operating northwest of Midway Atoll, though their exact position remained uncertain. Admiral Raymond Spruance, commanding Task Force 16 from Enterprise's bridge, had made the calculated decision to launch at extreme range, betting that catching the Japanese carriers vulnerable would justify the risk of sending his aircraft to the edge of their fuel capacity. The launch sequence began at 0700 hours. Enterprise turned into the wind, her bow rising and falling gently in the moderate swell. On the flight deck, 36 aircraft sat in precise formation. 14 Dauntless dive bombers of Bombing Squadron 6, 18 more Dauntless from Scouting Squadron 6, and 10 Wildcat fighters from Fighting Squadron 6 designated to provide escort. Each aircraft represented thousands of hours of manufacturing labor at Douglas Aircraft's plant in El Segundo, California, and Grumman's facility on Long Island. Each pilot had undergone training that lasted months and cost thousands of dollars. Each mission represented an investment that Japan's constrained industrial base could not match. The deck officer raised his flag, the signal for first launch. The lead Dauntless, piloted by Lieutenant Commander McClusky, advanced to the catapult. Deck crews attached the bridle, the cable that would connect the aircraft to the catapult shuttle. McClusky pushed his throttle forward, feeling his right Cyclone engine roar to full power. The launch officer confirmed all systems ready, swung his flag in a circular motion, then dropped it sharply. The catapult fired with a pneumatic hiss, and McClusky's 11,000-pound aircraft accelerated from stationary to flying speed in less than 3 seconds. The sudden G-force pressed him back into his seat as his Dauntless shot off Enterprise's bow and climbed into the morning sky. Before McClusky's aircraft had traveled 200 yards from the ship, the next Dauntless was already positioned on the catapult. 3 seconds later, it too launched into the air. The rhythm continued with mechanical precision. Position, attach bridle, signal, launch, repeat. Deck crews moved without wasted motion, each evolution identical to thousands of practice runs they had performed. Aircraft that didn't require catapult assistance rolled down the deck under their own power, using the carrier's 32-knot speed and the natural wind to generate sufficient lift for takeoff. The entire launch sequence, from first aircraft airborne to last, consumed 90 seconds. This achievement represented more than mere mechanical efficiency. It demonstrated institutional competence at every level of the American naval aviation enterprise. Pilots who could start engines and perform pre-flight checks with absolute reliability. Mechanics who maintained aircraft to standards that ensured engines would perform under maximum stress. Deck crews trained to move heavy aircraft with precision while working around spinning propellers and hot exhaust. Officers who could coordinate complex operations under time pressure without error. And underlying all of it, an industrial system that delivered aircraft, spare parts, and trained personnel in quantities that Japanese planners could barely comprehend. Japanese carrier operations, by contrast, reflected different priorities and constraints. The Imperial Japanese Navy's carrier force had pioneered many innovations in naval aviation, and their pilots were among the world's most skilled. But their launch procedures emphasized thorough preparation over speed. Japanese doctrine called for careful inspection of each aircraft before launch, methodical engine warm-up procedures, and conservative spacing between launches to ensure safety margins. These practices reflected both cultural preferences for perfection over expediency and practical concerns about limited replacement capacity for aircraft and pilots. The typical Japanese carrier required approximately 15 to 20 minutes to launch a similar strike package, roughly 10 times longer than Enterprise's 90-second evolution. This difference might seem minor in isolation, but in carrier warfare where striking first often meant winning, those extra minutes could prove fatal. A carrier caught with aircraft on deck, bombs and torpedoes exposed, and fuel lines pressurized for refueling, was extraordinarily vulnerable. Even a single bomb hit could trigger chain reactions that would destroy the ship. Speed in launching and recovering aircraft directly translated to reduced vulnerability windows. Commander Minoru Genda, arguably the Imperial Japanese Navy's most brilliant aviation tactician, understood these dynamics intimately. He had designed the Pearl Harbor attack and advocated for doctrinal reforms that would improve Japanese carrier operations. But Genda operated within institutional constraints that limited how radically procedures could change. Japanese naval culture emphasized flawless execution of established procedures over experimental innovation. Training programs focused on producing pilots of exceptional individual skill rather than operationally interchangeable crews. Maintenance practices prioritized aircraft longevity over maximum sortie rates. These choices made sense within Japan's resource constraints.
If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this.
With limited industrial capacity to replace losses, preserving aircraft and pilots justified accepting longer operational cycles. But the approach carried costs that became apparent only in combat against an opponent who had optimized for different objectives. American doctrine accepted higher equipment attrition rates because American industry could replace losses. American training produced larger numbers of adequately skilled pilots rather than smaller numbers of exceptional ones. American maintenance practices prioritized operational availability over equipment longevity. As McClusky's strike group formed up and set course for the Japanese fleet, the Enterprise immediately began preparing for their return. Deck crews repositioned barrier cables, spotted fire suppression equipment, and cleared the landing area. The ship's radar operators tracked the outbound strike, while simultaneously monitoring for incoming threats. Below decks, mechanics prepared replacement aircraft, and ordnance crews assembled bombs and torpedoes for the next mission. The carrier operated as an integrated weapons system where every evolution flowed into the next without pause. The Japanese carriers approaching Midway that morning represented the finest carrier force yet assembled. Vice Admiral Chuchi Nagumo commanded 4 fleet carriers: Akagi, Kaga, Soryu, and Hiryu. These ships had struck Pearl Harbor, destroyed the British Eastern Fleet in the Indian Ocean, and operated across the Pacific without serious challenge. Their combined air groups numbered over 200 aircraft, flown by pilots whose average experience exceeded 1,000 flight hours. By any conventional measure, this force should have overwhelmed the 3 American carriers defending Midway. But conventional measures proved inadequate for assessing the operational advantages American carriers had developed. While Japanese carriers could embark more aircraft, American carriers could launch and recover them faster. While Japanese pilots possessed superior individual skills, American doctrine emphasized coordinated group tactics that maximized collective effectiveness. While Japanese aircraft often showed superior performance in specific parameters, American aircraft demonstrated better reliability and easier maintenance. These cumulative advantages, none decisive in isolation, combined to create systemic superiority that Japanese commanders failed to anticipate. At 0920 hours, Nagumo faced a critical decision. His carriers had launched strikes against Midway Atoll at dawn, and those aircraft were now returning, requiring immediate recovery. Simultaneously, scout planes had finally reported American carriers operating northeast of his position. Standard doctrine called for launching immediate strikes against newly discovered enemy carriers, but his flight decks were crowded with returning Midway strike aircraft. The CAP fighters protecting his force were running low on fuel and ammunition, requiring landing and servicing. And the reserve strike force armed with torpedoes for anti-ship operations had been hastily rearmed with bombs for a second Midway strike when no American carriers appeared to be present. Nagumo decided to recover his Midway strike group before launching against the American carriers. This seemingly reasonable choice, prioritizing the preservation of aircraft and pilots already airborne, would doom his carrier force. The recovery operation required 30 minutes during which his carriers steamed in vulnerable condition with aircraft handlers scrambling to clear flight decks, rearm aircraft, and prepare for the outbound strike. During those 30 minutes, the carriers could not launch fighters to reinforce their defensive patrol or strike aircraft to attack American forces. Enterprise's strike group, navigating by dead reckoning toward the Japanese fleet's estimated position, arrived overhead at 0925. McClusky spotted the Japanese carriers far below, their flight decks crowded with aircraft in various states of preparation. The scene represented a dive bomber pilot's dream. High-value targets in vulnerable condition with inadequate fighter protection. McClusky deployed his squadrons for attack, and within minutes, 3 of Nagumo's 4 carriers were burning wrecks. The bombs that struck Akagi, Kaga, and Soryu did not sink those ships immediately, but they ignited catastrophic fires among the armed and fueled aircraft spotted on their flight decks, triggering secondary explosions that gutted the carriers internally. Within hours, all 3 had to be abandoned, and they would sink before the day ended. Hiryu, the 4th carrier, escaped initial destruction and launched a strike that damaged the American carrier Yorktown. But that afternoon, aircraft from Enterprise found and destroyed Hiryu as well. By sunset on June 4, 1942, the Imperial Japanese Navy had lost 4 fleet carriers, over 200 aircraft, and more than 3,000 trained personnel, including many of their most experienced pilots and mechanics. The Battle of Midway's outcome hinged on numerous factors: American intelligence that provided advance warning of Japanese intentions, tactical decisions by commanders on both sides, and the courage of American pilots who pressed home attacks under intense anti-aircraft fire. But underlying all these immediate causes was the systematic operational advantage American carriers possessed in launch and recovery cycles. Enterprise's ability to put 36 aircraft airborne in 90 seconds meant that when opportunity appeared, American forces could exploit it immediately. Japanese carriers, requiring 15 to 20 minutes for equivalent operations, could not respond with similar speed. This operational tempo advantage cascaded through every aspect of carrier operations. American carriers could launch multiple strike waves in the time Japanese carriers prepared one. American carriers could recover aircraft, rearm them, and launch again while Japanese carriers still worked through single cycles. American carriers could maintain continuous defensive patrols without degrading offensive capacity. These advantages, invisible in peacetime fleet reviews or paper comparisons of aircraft characteristics, proved decisive in combat where minutes determined life or death for ships and thousands of men. The engineering sophistication required to achieve 90-second launch cycles extended far beyond the flight deck's visible operations. Below decks, Enterprise housed massive machinery spaces where 8 Babcock and Wilcox boilers generated steam to drive 4 turbines producing a total of 120,000 shaft horsepower. This power plant could push the carrier to 33 knots maximum speed, though 32 knots represented the optimal velocity for flight operations, generating sufficient wind over the deck while preserving fuel economy. The carrier's fuel bunkers held more than 4,000 tons of Navy special fuel oil, providing cruising range exceeding 12,000 nautical miles. The ship's 2 catapults represented mechanical marvels in their own right. Each hydraulic catapult used pressurized fluid to drive a piston connected to a shuttle that ran in tracks along the flight deck. When activated, the hydraulic pressure accelerated the shuttle and its attached aircraft from 0 to launch speed in approximately 70 feet of travel. The forces involved were tremendous. A fully loaded Dauntless weighing 11,000 pounds required acceleration equivalent to 3G forces sustained for approximately 3 seconds. The catapult had to deliver this performance reliably, mission after mission, without mechanical failure that would disable flight operations. Maintaining this equipment under combat conditions required skilled technicians working in conditions that ranged from uncomfortable to dangerous. The machinery spaces operated at temperatures exceeding 100 degrees Fahrenheit, filled with the smell of fuel oil, steam, and hot metal. Vibration from the turbines and propeller shafts made prolonged work physically exhausting, and the ever-present danger of fire, explosion, or battle damage meant that engineering crew members accepted risks comparable to those faced by pilots and deck crews. The ordnance handling systems that supplied bombs, torpedoes, and ammunition to aircraft represented another critical component of the carrier's operational capability. Enterprise's magazines, located deep in the ship below the waterline for maximum protection, stored hundreds of tons of explosives in carefully controlled conditions. Ammunition elevators lifted ordnance from magazines to hangar deck and flight deck levels where ordnance crews assembled weapons and attached them to aircraft. Each bomb required careful handling. The 1,000-pound general-purpose bombs that proved so effective at Midway contained nearly 700 pounds of explosive, enough to destroy a city block if detonated accidentally. The doctrine governing ordnance handling reflected hard lessons from earlier carrier operations. American carriers in the Coral Sea battle the previous month had experienced close calls when Japanese bombs detonated near armed and fueled aircraft, triggering fires that nearly proved catastrophic. The Navy had refined procedures to minimize time that armed ordnance remained exposed on flight decks, and to ensure that fueling operations never occurred simultaneously with ordnance loading. These safety protocols added complexity to flight deck operations, but proved essential for preventing the kind of catastrophic fires that destroyed the Japanese carriers at Midway. Japanese carriers, by contrast, had developed different ordnance handling procedures that prioritized operational flexibility over strict safety protocols. Japanese doctrine permitted simultaneous fueling and arming of aircraft, accepting the increased fire risk in exchange for faster turnaround times between missions. This approach worked adequately when Japanese carriers operated without serious opposition, but at Midway it proved fatal. When American dive bombers arrived overhead, they found Japanese flight decks crowded with aircraft in precisely the condition most vulnerable to attack: fueled, armed, and unable to launch. The human dimension of carrier operations deserves examination beyond mechanical and procedural considerations. Enterprise's crew numbered approximately 2,200 officers and enlisted men, each performing specialized roles that required extensive training. Flight deck crews who positioned aircraft and managed launches wore color-coded jerseys indicating their specific functions: yellow for aircraft directors, blue for tractor drivers, red for ordnance handlers, green for catapult and arresting gear operators, and brown for plane captains responsible for individual aircraft. This color coding allowed instant visual identification of personnel in the chaotic environment of flight operations where verbal communication was nearly impossible over engine noise. The training pipeline that produced these skilled specialists began months before they ever reported aboard Enterprise. Navy technical schools taught basic skills relevant to each rating, but real proficiency came only through supervised practice aboard ship. Junior sailors learned from experienced petty officers who had performed the same tasks hundreds or thousands of times. The Navy's rotation system ensured that experienced personnel never all transferred simultaneously, maintaining institutional knowledge and operational continuity. This systematic approach to crew training contrasted sharply with Japanese practices where elite status and personal relationships often determined assignments more than systematic skill development. Aviation mechanics who maintained Enterprise's aircraft represented another critical specialty requiring extensive training. Each Dauntless scout bomber contained thousands of components that had to function reliably under extreme conditions. The Wright's Cyclone radial engine that powered the aircraft delivered 1,000 horsepower through 9 cylinders arranged in a star pattern. This engine had to start reliably, run smoothly at varying power settings, and maintain performance despite exposure to salt air, temperature extremes, and combat damage. Mechanics performed routine maintenance between missions and major overhauls at scheduled intervals, working to tolerances measured in thousandths of an inch while using tools that would seem primitive by later standards. The cultural attitudes that American and Japanese forces brought to carrier operations reflected broader societal differences that influenced combat effectiveness. American military culture emphasized systematic problem-solving, mechanical reliability, and operational efficiency. Training focused on producing standardized procedures that could be executed by adequately trained personnel rather than requiring exceptional individual skill. Equipment design prioritized ease of maintenance and high operational availability over maximum theoretical performance. These choices reflected American industrial society's values: practicality over elegance, efficiency over tradition, and systematic process over individual brilliance. Japanese military culture valued different attributes: individual excellence, spiritual commitment, and adherence to established forms. Training produced pilots of extraordinary skill whose individual capabilities exceeded their American counterparts. Equipment design sometimes prioritized performance over reliability, producing aircraft that could outperform American types in specific parameters but required more maintenance and suffered lower availability rates. Procedures emphasized perfect execution over speed, reflecting cultural preference for quality over quantity. Neither approach was inherently superior in all circumstances. Japanese training methods produced naval aviators whose individual skills exceeded American pilots, particularly early in the war. Japanese aircraft like the Zero fighter demonstrated performance that shocked American opponents when first encountered. Japanese operational doctrine had pioneered carrier aviation tactics that all nations studied. But the systematic advantages American methods provided in operational tempo, equipment reliability, and replacement capacity proved decisive when the two systems clashed in sustained combat. The 90 seconds that Enterprise required to launch 36 aircraft represented the visible outcome of this systematic approach applied across every aspect of carrier operations. The flight deck crews who positioned aircraft with precision had drilled those movements until they became automatic. The catapult operators who launched planes with split-second timing had performed the evolution hundreds of times. The pilots who started engines and performed final checks without error had internalized procedures through repetitive practice. The mechanics who ensured every aircraft was mission-ready had access to abundant spare parts and technical documentation. And underlying all of it, an industrial base that could replace losses and an institutional culture that prioritized operational effectiveness over traditional forms. Japanese commanders who survived the Battle of Midway struggled to comprehend what had destroyed their carrier force so quickly. The tactical sequence was clear. American dive bombers had struck while their carriers were vulnerable during aircraft recovery operations. But the deeper causes, the systemic advantages that allowed American carriers to maintain operational tempo Japanese carriers could not match, remained less obvious. Intelligence reports described American carrier operations in mechanical terms, documenting launch rates and sortie cycles. But these statistics failed to convey the comprehensive institutional superiority they represented. Vice Admiral Nagumo, who survived the battle though his flagship Akagi did not, provided testimony in after-action reports that revealed the cognitive dissonance Japanese commanders experienced. He acknowledged that American dive bombers had attacked during a vulnerable moment, but framed this as unfortunate timing rather than the predictable outcome of differential operational capabilities. He noted that American carriers had launched strikes more quickly than expected, but did not analyze why Japanese carriers required longer cycle times or what could be done to close that gap. His reports, like those of other survivors, focused on tactical specifics of the battle while avoiding the broader strategic implications. The Imperial Japanese Navy's institutional response to Midway similarly avoided confronting systemic deficiencies. Official histories characterized the battle as a defeat caused by tactical errors and bad luck rather than fundamental operational disadvantages. Training programs continued emphasizing individual pilot excellence over systematic crew coordination. Equipment procurement prioritized aircraft performance over reliability and maintainability. Carrier operational doctrine retained conservative launch procedures despite evidence that American speed advantages proved tactically decisive. This institutional resistance to learning from defeat would cost Japan dearly in subsequent battles as American carriers continued to demonstrate operational superiority. The USS Enterprise continued operating in the Pacific through the remainder of 1942 and into 1943, participating in every major campaign from Guadalcanal through the Marianas. Her crew refined the procedures demonstrated at Midway, incorporating lessons from each engagement. Launch cycles became even more efficient as experienced deck crews trained replacements and passed along techniques learned through practice. The carrier survived multiple bomb hits and near misses, testament to her robust construction and her crew's damage control capabilities. By war's end, Enterprise had earned more battle stars than any other American warship, participating in nearly every significant engagement in the Pacific theater. The operational advantages Enterprise and her sister carriers demonstrated at Midway would characterize American naval aviation throughout the war. Subsequent carrier classes built on lessons learned, incorporating improved flight deck layouts, more powerful catapults, better hangar arrangements, and enhanced damage control systems. The Essex-class carriers that entered service starting in 1943 embodied systematic refinements that made American carrier operations even more efficient. These ships could launch larger air groups faster than Enterprise, while providing better working conditions for their crews and improved survivability against battle damage. Japanese carrier construction, constrained by limited industrial capacity and competing priorities, never matched American output in quantity or incorporated equivalent systematic improvements in quality. The carriers Japan built to replace those lost at Midway reflected incremental improvements, but failed to address fundamental operational deficiencies. Training of replacement pilots, limited by fuel shortages and inadequate training infrastructure, never restored the proficiency levels demonstrated by the Pearl Harbor attack force. By late 1943, American carrier air groups routinely overwhelmed Japanese defenders through superior numbers, better coordination, and more reliable equipment. The statistical disparity grew steadily more pronounced as the war progressed. By 1944, the United States operated more than 100 aircraft carriers of various types, from massive fleet carriers to smaller escort carriers built on merchant ship hulls. American industry delivered aircraft at rates exceeding 15,000 per month at peak production. American training facilities graduated thousands of pilots annually, providing replacement capacity that allowed aggressive operational employment without concern for attrition. American logistics delivered fuel, ammunition, spare parts, and personnel to forward bases with systematic efficiency that kept carriers operating at high tempo despite distances spanning thousands of miles. Japan, by comparison, struggled to keep a dozen carriers operational, produced fewer than 2,000 aircraft monthly, and watched its pilot training program deteriorate as experienced instructors died in combat and fuel shortages restricted flying hours. The gap that existed at Midway, measured in minutes of launch cycle differences, had widened into chasms measured in orders of magnitude across every dimension of carrier operations. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.